Welcome everyone, Costin here with a discussion about Nvidia's 50 series GPUs that are going to be coming out soon enough. Now, we got a bunch of marketing information from Nvidia, which a lot of people will rightly call into question, and then we got a bunch of actual data on what these GPUs are going to do. Various leaks, various sources, the tech media is all over it. There are quite some very notable takeaways on what the 50 series is going to offer compared to the 40 series supercards. Now, I'm Cyberpunk 2077, which is kind of like the gold standard of graphics. I'll get to that in just a second, though, on Cyberpunk and the things that matter. But here's what you need to know about GPUs, essentially. Memory speed, CUDA cores, RT cores, and Tensor cores. Memory is very easy to understand, right? The more you have, the faster it is, the better you're off. Pretty simple. It does seem there are going to be memory improvements with the 50 series dependent on the model. That's not really a controversial subject, so we're going to get better memory. Some of the tech media are complaining like, well, some of these GPUs could use more memory. I'm going to say this out loud. For 1440p gaming, you, for the most part, don't need more than 12 gigs. I say this as someone who's been playing on a 47 Ti. I don't have 16 gigs of memory. I've been playing with 12 gigs. Outside of a handful of cases, at 1440p is good enough. So, but mind you, 16 gigs, that's great, right? If we could all have GPUs with 16 gigs, that would be great. But I'll talk about 1440p and 4K in just a moment. But with regards to CUDA cores, Tensor cores, RT cores. Well, CUDA cores are general purpose cores. They handle what you'd consider normal gaming rendering, or rasterization performance, if you will. Then you have ray tracing cores, which handle ray tracing performance, and then you have Tensor cores, which handle AI performance. Now, based on the statistics we have, the data sheets we have, between the 40 series supercards, specifically the supercards, and the 50 series GPU lineup, what we're going to get is a very small increase in terms of CUDA cores, small increase in terms of RT cores, though Nvidia has claimed that they're more optimized. We'll see about that. And a significant increase in terms of Tensor cores, AI cores. So we're looking at the doubling, if not tripling, of AI cores. And that is really very important in this day and age. Why is that so important? Is because in this day and age, I'm sure a lot of people that own an Nvidia GPU at least, or an AMD GPU, you're no longer just playing with like normal rasterization performance. And this is not even a question of ray tracing, really. Forget ray tracing for a moment. There are other things. There are things like FSR, there are things like DLSS, there is DLAA, and there is RTX HDR. And those do use AI cores in Nvidia's case. So for instance, over here in the footage you're seeing, I have HDR enabled. This is going to be an HDR video, even if it's going to take YouTube some time to process it. But in this video, I have HDR off in the game. Why is that? Well, because in every single game that I've been playing, since I got a 40 series GPU and a good HDR display, I've been using RTX HDR. RTX HDR in the vast majority of games looks better. Cyberpunk, it's kind of discussion on that subject because Cyberpunk does have good HDR implementation. The vast majority of games don't have good HDR implementation, if they even have it at all. But here's the catch with RTX HDR, which uses Tensor cores, which uses AI. RTX HDR in this particular case, I can't show the difference because switching from HDR to non-HDR in a video is something that wouldn't work on YouTube. It's an annoyance with YouTube trying to show this because you can either have a video that's HDR or a video that's not HDR. You can't have a video that's buff. That's pretty annoying. Or a portion of it that's not and the rest of it on. But if I turn RTX HDR off, I gain about 10 to 15 FPS on average. Just the FPS situation over there. So it is expensive from an FPS perspective. Absolutely. It looks great. The performance impact is not really noticeable in most games, but it is obviously noticeable in something that's stressing your system, like Cyberpunk. And that is a key point. Nvidia doubling or tripling the number of AI cores will improve the performance on things like RTX HDR, DLAA, and DLSS. Now, if I look at my graphics over here, I do not have DLSS on. I don't have ray tracing on. I have DLAA on. DLAA is not DLSS. DLSS does reduce your resolution, but tries to reconstruct the image in such a way that, it looks the same. We can also talk about displays. But DLAA is a really good anti-aliasing method. In fact, the best method of anti-aliasing that exists on the market. Forget every other anti-aliasing method that exists in any other game. This is flat out the best method of getting anti-aliasing in a game. But if I turn on DLSS, quality mode, just quality, and I go back to the game right here, it jumps over 100 FPS. But I am losing quite a bit of resolution for that, to be sure. Is it noticeable? Kind of. It's hard to say. The reason it's hard to say partly comes down to the display I'm using. For me, it's difficult to say. I can notice it if I look at certain sections, sure, but it is hard to say because the display I'm using on an LG C4 also has its own upscaling. Like, I have a 4K display, and I can tell you I struggle very hard to notice the difference between playing a game at 4K native versus 1440p native. That's another aspect. You'll see a lot of people pushing 4K gaming, but reality, is 4K gaming worth it considering all the upscaling technology we can have on displays alone? Not necessarily so. So that is one aspect with regards to it. If I turn on ray tracing, and this is gonna hurt a lot, but if I turn on ray tracing, my FPS goes down to 40. Keep in mind, this is not regular ray tracing, this is path tracing. So if I turn off path tracing over here and just go with normal quote-unquote ray tracing over here, and we have ray trace lining, ultra, not even psycho, like just ultra ray tracing without path tracing, and we look at the game right here, it's 60, 50, all that. So ray tracing itself takes another 20 or so FPS. Path tracing takes another 20 off the top of that. So ray tracing is expensive if you want it. Is there a difference? Yes, there is. You may not notice it necessarily in video, but if you're playing a game with ray tracing, or if you're playing a game with path tracing, the difference is pretty damn substantial, especially between regular ray tracing and this. Now, granted, path tracing is very, very limited, but it does get noticed. But yeah, 40 FPS is not especially great. And also my MS, my latency, has gone up from 30 or so to 45, 46. That's why ray tracing cores matter. AI cores matter for DLA. Are we going to get better path tracing performance with the 50 series? Nvidia is claiming better performance. I guess we'll see on that. But right now I'm at 42, 45 ms, so I got anywhere between 12 to 15 ms in the game. Even 20, like it jumped over there to 50 ms when I was moving, but just standing still. So that is what you get, ray reconstruction, path tracing, etc. They are improving ray reconstruction technology. That's also another thing that they're doing with the 50 series, and that is all important. But yeah, obviously 40 FPS is not what you'd want when playing Cyberpunk. However, when you have a G-Sync monitor and reflex boost mode on, let me just say that it isn't necessarily as horrible as it might look in certain cases, but like in terms of response time, let me just tell you this, like the way my character feels, like the way the camera feels right now, it's pretty solid. But let me restart the game, because I will need to restart the game to enable frame generation, because yes, that is what happens in this game. So yeah, just got to restart it to get it working. So, with frame generation on, how are things running? Horribly. So my MS, which was 50, has jumped over 80, even 100. My FPS has gone up to 60, 40. So, with just DLSS quality enabled with path tracing, I'm at 40. I gained 24, 23 FPS over here. But yeah, this is not really great. This is not really playable. But that's because frame generation does require a certain amount of baseline performance in order to get it running. So yes, optimization of games do matter, and baseline performance does still matter. However, that's not what Nvidia is focusing. I mean, Nvidia can't focus on optimization. That's on the developers. You want to blame Nvidia for that? Go right ahead. What matters, and although I do think like frame generation does start getting better the more you play, like it has a moment, it takes a while to boot up, but once it does boot up, it does start feeling better. Right now I'm like heading toward like ATMS. But still, if I turn off, not ray tracing, just path tracing, if I turn off ray tracing over here, I'm at 84, 85 FPS with 60 ms. So I'm gaining a roughly, let's say, 15, 20, 25 actually, 25 or so ms. But I'm also getting closer to 90 FPS. Graphically, is it notable? No. Is the response time notable? Yes, it can be, especially if you're in a competitive situation. But if you're someone who cares that much about the competitive situation, you would make a lot of sacrifices on that subject. And yes, you wouldn't want to turn on frame generation. But here's the key. Nvidia is improving RTX HDR performance. They're improving DLSS performance. They're improving frame generation, not just in terms of how it runs, but also in how it looks. That's what we're going to get with the 50 series of GPUs. Would it be better if they gave us, let's say, quote-unquote, brute force performance or rasterization performance? Kind of. I would say, given the fact that nowadays you kind of want to run a game, if you have an Nvidia GPU, you kind of want to run it with ray tracing, and you certainly want to run it with RTX HDR. I would personally say that what they're doing can potentially make a very significant difference. It's a question like, what's the quality that we're gonna get with DLSS, with the new DLSS? What's the performance that we're going to get with the new DLSS, and what's the performance that we're going to get with frame generation, and the quote-unquote fake frames. I mean, I don't really care, like, ultimately how a frame, it's all fake frames, it's all virtual anyway, but what I'm interested in is image quality. Does it look good? Does it look good? I might die here, by the way, because, yeah, I'm not really in a situation to actually pick a fight right here with the police, especially not Psycho Squad. Anyway, there we go. Yes, V has a really good weapon over here, my guy. But you're gonna get better AI performance, so that means DLSS, RTX HDR. Even if you don't care for any kind of upscaling or frame generation, your game should run better, because you can use RTX HDR with less of a performance impact, hopefully. That's what we're hoping for. That's what we need to see. What is going to be the performance gain? What is going to be the visual fidelity in a game that's using RTX HDR and just regular DLA, which again is not an upscaling technology. It's an anti-aliasing technology, very different, and it's much better than everything out there that currently exists on the market. Like, for me personally, you know, I would play it like this. Maybe I would turn down some of the ray tracing a bit, you know, from ultra to, let's say, medium over here. You know, get even more FPS, or at least smoothness. Maybe I won't gain that much FPS, but clearly the 4070 Ti is not necessarily rated to handle this game. I could set my DLSS to balanced, right? And maybe that will make a difference. Maybe. Sometimes DLSS makes a huge difference, sometimes it doesn't make a huge difference. Sometimes it takes a game that's a completely unplayable mess. I'm not talking about Cyberpunk right here, but sometimes you have a situation where it takes a completely unplayable mess of a game and actually makes it playable. So those are the things that you gotta be keeping in mind when you're talking about all of this. This brings me to the rather infamous case of Jedi Survivor, a game that launched without DLSS support, without frame generation support because it was an AMD game, and because Respawn didn't do a great job with the optimization of the PC version, and also the Nouveau, which they took out. And yes, the game runs better now that they did take it out from the game. Much better, actually, more stable. See, the problem with things like the Nouveau is not necessarily that the frame rates you're getting are going to be lower. And yes, that loading screen issue has been there since pretty much day one of the game, or the game would crash in this area. But right now, I'm getting 110 FPS, around 54, 56 ms in this area. And this, by the way, is the worst performing area of the entire game, and it's also as close to a central hub as you're gonna get in this game, as there are any in the title. And then if we go turn off frame generation, turning it on can be a bit of a problem when you have it turned off, but without restarting the game. But if we turn it off, we get to like 74, 75 FPS, and we are still at 51, 48, 47. So we gain some MS, we lose quite a bit of FPS in the process, and that MS may be a lie because it's right now 52, 53. Okay, let's say we go from an average of around 60 to 52. In the video that Digital Foundry showed on the subject of MS, they showed that FrameGen 4x, as opposed to 2x, which is what we're getting right here, or what we were getting just a second ago. The difference was roughly 7, 8, 10 ms in terms of response time. Now in this game, the difference between FrameGen on and off may not be so significant because of reflex boost mode. So reflex is used by default when you have FrameGen enabled, but I don't think there's an option to turn it on separately in this title. So you're not really going to get a better response time over here. Or whatever response time you're getting by turning FrameGen off, you're losing because you don't have reflex mode on. So that is something of a problem right here. I would possibly run this game without frame generation. I think 75 FPS right now in this game is really good. Don't get me started on how horribly this game ran at launch. They literally doubled the FPS. Granted, I did upgrade my computer in the meantime, but I did use the same GPU. I upgraded my CPU, and I don't think I've seen a game that doubled my frame rate in terms of CPU just because I upgraded my CPU. I mean, sure, it makes a difference, not necessarily that kind of a difference, gotta be said on that subject. Still, obviously developers do need to do a better job optimizing their games. I don't dispute that. Far from it. It has to be a case, but I think Nvidia's focus on improving AI tech, and keep in mind that Digital Foundry's video with regards to their response time of the game was on the same GPU. It's not like they were testing a 40 series GPU versus a 50 series GPU. No, they were testing different types of frame generation in terms of MS over there and showing those numbers on screen. So we don't know what kind of frame generation we would get with like 2x, and what kind of response time we would get with frame generation between the 50 series and an equivalent 40 series GPU in terms of utter performance, or as close to utter performance in terms of like ray tracing cores, CUDA cores, and all that. That is obviously one of the big subjects of discussion, and one of the things reviewers and the tech media is actually going to have to jump in on that subject, I think. But just some food for thought. Costin signing out. Don't forget to subscribe, like, and enable notifications, and stay tuned for more.